In my last video, I talked about how to rationalize the denominator or get rid of the radicals in the denominator of a fraction. And I want to do a few more examples of these with some that are a bit more difficult. Some that have binomials both in the numerator and the denominator of the fraction. So let's look at this. 4 plus the square root of x over the square root of x minus 7. Okay, so again, we're concerned with having a radical in the denominator. This one up here is fine. It's not a problem, but as long as we have a radical in the denominator, our answer is not in simplest form. And so we want to rationalize the denominator, and that means get rid of the radicals in the denominator. And in order to do that, we're going to need to multiply by the conjugate of the denominator. So the conjugate will have the same terms, square root of x and 7, but instead of having a subtraction sign, you'll do the opposite, and your conjugate will have an addition sign. If this had been a plus, then in your conjugate it would be a minus. So square root of x plus 7 is the conjugate of square root of x minus 7. We're going to multiply the top and bottom of this fraction by square root of x plus 7. I also want to remind you that the reason we're able to do this is because anything over itself is 1. So we're really multiplying this by a version of the number 1, which means we are not changing its value at all. We're just writing it in a different form. Now, since we've got binomials on the top, we're going to have to do the distributive property. Some of you might use the term FOIL to help you remember the steps when you're multiplying a binomial times a binomial. But first we'll distribute the 4 through this second binomial. That'll give us 4 square roots of x plus 28. And then we'll multiply the square root of x times the second binomial. So the square root of x times the square root of x is x. And the square root of x times 7 is 7 square roots of x. On the bottom, we can also do the distributive property here. Remember, when we multiply conjugates together, the outer and the inner terms of FOIL will cancel each other out, but we'll go ahead and work that out and show you where that happens. Square root of x times square root of x is x. When we multiply the square root of x times positive 7, we get positive 7 square roots of x, then negative 7 square roots of x, and then 7 times 7, or negative 7 times 7 is negative 49. And just as it should, those cancel, which is why rationalizing the denominator by multiplying by the conjugate helps us get rid of the radicals in the denominator. So what we have now, let's see if we have any like terms that we can combine on top. We do here and here. We'll have an x plus, if we combine these two, we'll have 11 square roots of x, and then plus 28. And then on the bottom we will have x minus 49. And some of you might think this looks worse than what we started with, and I tend to agree. However, the whole point is to get rid of the square roots or the radicals that are in the denominator, and we did accomplish that. So let's look at another one. We're just going to do just 2 or 3 in this video to get us through this. Let's see. How about 2 square roots of 3 plus the square root of 7 on top over 3 square roots of 3 minus the square root of 7. Okay, again, we're not concerned with the radicals in the numerator. We want to rationalize the denominator. We want to get rid of these radicals. And to do that, we'll multiply both the top and the bottom of this fraction by the conjugate of the denominator. Both of these terms will stay the same. Since this is a minus, in the conjugate it will be a plus. And we'll multiply the top and bottom by that same binomial. Alright, again, we're going to have to do the distributive property up here. And sometimes this can be a lot to keep up with. I like to use the box method for multiplying binomials. It just kind of helps me keep my work neat and keep up with what's being multiplied. You can write your binomials on the sides of the box, so you have 2 square root of 3 plus square root of 7, that's this first one. And then down the side we'll write the terms for this second one that we're multiplying, 3 square root of 3 plus the square root of 7. And then we'll fill in each box by multiplying the terms that are on the sides of that box. So for this first box, we'll multiply 2 square roots of 3 times 3 square roots of 3. Well, 2 times 3 gives us 6. The square root of 3 times the square root of 3 gives us 3. And then we'll multiply those together and get 18. So our first term we get will be 18. Now we'll multiply 3 square roots of 3 times positive square root of 7, and that's going to be 3 square roots of 21. Then we'll multiply 2 square roots of 3 times the positive square root of 7, and that'll be 2 square roots of 21. Then we'll multiply square root of 7 times square root of 7, and that is 7. Now, if you'll notice, you can go ahead and kind of spot your like terms here. We have an 18 and a 7, that's going to make 25. And we have 3 square roots of 21 plus 2 square roots of 21, so that's going to be 5 square roots of 21. So that's what we'll get on top there. You'll get the same thing if you just multiplied it out using the distributive property. Again, this just to me is a nice visual, so I can see exactly what I'm multiplying and what my 4 answers were, and then what my like terms are that I can combine. You could do the same thing on the bottom as well. However, we do know that our outer and inner terms should end up being opposites and will end up canceling. So if you trust that will always happen, then you can just multiply the first terms together. 3 square roots of 3 times 3 square roots of 3. Well, 3 square roots of 3 times 3 square roots of 3 is 9 times 3, which is 27. So we'll have a 27 on the bottom. I know that whatever I get when I multiply these and whatever I get when I multiply these should end up canceling each other out. And then last you would multiply these two together. Square root of 7 times square root of 7 is 7, and it would be minus 7. And that, you can see, got rid of all of our radicals in the denominator. Again, if you need to multiply this out, or you can do the box method, you can do that. But if you trust that you have found the conjugate correctly, then you know that those two terms end up canceling each other out every time. So now we're left with 25 plus 5 square roots of 21 on the top, and 27 minus 7 is 20 on the bottom. Now to simplify this, we look basically here, here, and here. All of those numbers are divisible by 5. And so we can simplify this by dividing those all by 5. 25 divided by 5 is 5. This 5 divided by 5 is 1, so I can write the 1, or I don't have to, and just put square root of 21. And then 20 divided by 5 is 4. So we have 5 plus the square root of 21 over 4. Now that is the same, just if you were wondering, as 5/4 plus the square root of 21 over 4. These are the same. Alright, let's see, let's do at least one more example. How about this one? 3, maybe I better write it down here. 3 square roots of 2 plus 2 square roots of 5 over square root of 2 minus 4 square roots of 5. Alright, we're going to multiply the top and the bottom by the conjugate of the denominator. which is going to be the square root of 2 plus 4 square roots of 5. Same thing up here, plus 4 square roots of 5. Again, whatever you multiply the bottom by, you got to multiply the top by, because this is a version of 1. Alright, I added those parentheses in here, and you can do it here as well. You want to multiply the top. I think I will use my box method again. I'm going to come right over here and use this space. I have 3 square roots of 2 plus 2 square roots of 5 times the square root of 2 plus 4 square roots of 5. Alright, so I'll multiply the sides of the box to find the products, and those will go in these squares. 3 square roots of 2 times square root of 2 is 3 times 2, which is 6. 2 square roots of 5 times the square root of 2 is 2 square roots of 10. 3 square roots of 2 times 4 square roots of 5 is 12 square roots of 10. And 4 square roots of 5 times 2 square roots of 5 is 8 times 5, because the square root of 5 times the square root of 5 is 5, which is 40. Alright, we can see here our like terms that we can combine. We have 40 and 6, that's 46, and we have 14 square roots of 10. And on the bottom, again, if we multiply the first two terms, that's going to give us 2. We know when we multiply these two terms and we multiply these two terms, they're going to give us opposites, which are going to cancel out. And so we can go right on and multiply these two, which is going to give us minus 16 times 5. I'll leave that to be done in the next step. So I have 46 plus 14 square roots of 10 over 2 minus 80. Yuck, that's negative 78 on the bottom. Okay, I would like to simplify this a little bit. I don't like a negative on the bottom. I'm looking at those 3 numbers, wanting to see if I can simplify those at all. I know they're all even, so I know at least I can divide them all by a 2. I'm going to go ahead and divide them by negative 2, so that I can get this negative off the bottom. Alright, so if I divide this by negative 2, that's going to leave me with negative 23. If I divide this by negative 2, that's going to leave me with negative 7 square roots of 10. And then if I divide 78 by negative 2, that's going to leave me with 39. And I don't see anything else that will go into these 3 numbers, so this is in simplest form, and we are finished.